Hey explorers! Today we're zooming in on the world of physics and astronomy. Now, let's dive into the fascinating universe of these fields and discover what makes them so important. Before we get into the careers, let's first break down the basics of physics and astronomy. What is physics? Physics is the study of matter, energy, and the forces that govern how everything in the universe works. Now that we know what physics is, let's look at how astronomy ties into the picture. What is astronomy? Astronomy is the study of stars, planets, galaxies, and the universe beyond Earth, using physics to understand space and time. With these definitions in mind, let's explore why understanding physics and astronomy is so essential to us. Why are physics and astronomy important? Both are important because they help us understand how the world and universe function, inspire discovery, and lead to innovations like GPS, medical imaging, and space exploration. They fuel curiosity and solve real world problems with science. Now, let's see what careers are available for those who want to work in these fields. Ready to explore some of the exciting careers that play a key role in physics and astronomy? Let's jump in. First up, physicists and astronomers. Physicists and astronomers are scientists who study the laws of nature and the universe. Physicists research matter, energy, motion, and forces. Astronomers study celestial objects like stars, planets, and galaxies. They mostly work in labs, offices, or observatories. Common workplaces include universities, government research labs, and private tech or defense companies. Now that we know what they do, let's see how these professionals use physics and astronomy in their work. How are they involved with physics and astronomy? Physicists study matter, energy, and forces using math and experiments. Astronomers apply these laws to space, use physics to understand stars, black holes, and the origins of the universe. Both rely on advanced physics concepts like relativity, thermodynamics, and quantum mechanics. Moving on to another interesting career in science. Next up, we have atmospheric scientists. Atmospheric scientists study weather, climate, and the atmosphere. They analyze weather patterns, forecast storms, study climate change, and model atmospheric conditions. They mostly work in offices, weather stations, and research labs. The most common workplaces are NOAA, National Weather Service, TV stations, universities, and environmental consulting firms. How are they involved with physics and astronomy? They use physics, especially thermodynamics and fluid dynamics, to study and predict weather, climate, and energy transfer in the atmosphere. Some also explore planetary atmospheres, contributing to astronomy through missions and climate models for other planets. And now, let's learn about another fascinating career. Lastly, we have aerospace engineers. Aerospace engineers design aircraft, spacecraft, satellites, and missiles. They develop and test flying machines and space technology, as well as work on various systems. They often work in offices, manufacturing plants, or labs. Common workplaces include NASA, Boeing, Lockheed Martin, military contractors, and private space companies. So, how do these engineers apply physics and astronomy in their work? They apply physics to design aircraft and spacecraft using mechanics, aerodynamics, and heat transfer. Their work supports astronomy through the development of space vehicles, telescopes, and planetary probes that explore the universe. Now that we've seen these exciting careers, let's dive deeper into which careers are the most STEM heavy. The first most STEM heavy careers are physicists and astronomers. Let's start with education. Physicists and astronomers typically need a PhD in physics, astronomy, or a related field to work in research and academic positions. Some entry level jobs in the federal government may prefer to hire applicants with a bachelor's or a master's degree in physics. Undergraduate programs usually include courses in physics, calculus, computer science, and laboratory work to build a solid foundation. Do you need a license or certification? There are no formal certifications or licenses required to become a physicist or astronomer. However, depending on their specialization or workplace, some professionals may pursue optional certifications in lab safety, data analysis software, or specialized instruments. These are not mandatory but can enhance expertise and job opportunities. So, what does a typical day actually look like for a physicist and astronomer? Physicists and astronomers often work full time, over 40 hours per week. Their work involves conducting experiments, analyzing data, creating models, and writing scientific papers. Astronomers occasionally do nighttime telescope work, but most rely on data from remote instruments. Collaborations and presentations are common. Thinking ahead, what classes in high school will help you prepare? Students interested in becoming physicists or astronomers should take courses in physics, chemistry, algebra, calculus, statistics, and computer science, research based science electives for valuable skills. They may also want to develop qualities like analytical skills, communication skills, critical thinking skills, interpersonal skills, math skills, problem solving skills, and self discipline. Now for the big question: how much can you earn in this career? As of May 2024, physicists earn a median annual wage of $166,290, while astronomers earn $132,170. The top 10% of earners in both fields make over $190,000 annually. Salaries vary by employer, location, education level, and experience. Physicists working in private industry or government research often earn the highest wages. And finally, is this job in demand? Employment for physicists and astronomers is projected to grow about 4% from 2023 to 2033. Job prospects are strongest for those with advanced degrees and skills in mathematical modeling, data analysis, and computer simulations. Continued demand in technology, defense, healthcare, and environmental research will keep this field relevant and valuable. Which career designs aircraft, spacecraft, satellites, and missiles? Aerospace engineers. What kind of education do you need? Most aerospace engineers need a bachelor's degree in aerospace engineering or a related field. Advanced degrees may enhance opportunities, especially in specialized areas like propulsion systems or spaceflight technologies. Some positions, particularly those involving national defense, may require security clearances. What licenses or certifications should you expect? There are no formal licenses or certifications required by law to work as an aerospace engineer. However, depending on their role, some engineers may obtain security clearances, and professional engineers may pursue licensing for certain types of engineering responsibilities, especially in governmental or public sector positions. Curious about what they do all day? Aerospace engineers typically work full time, over 40 hours per week. Daily tasks include designing, testing, analyzing aircraft or spacecraft systems, evaluating blueprints, developing prototypes, and troubleshooting to resolve design or safety issues. They collaborate with others, review projects, and ensure compliance with regulations and performance standards. If you're in high school, these are the courses that'll give you a head start. Students aiming for this career should focus on calculus, algebra, trigonometry, physics, chemistry, computer science, engineering design, and robotics for experience. They may also want to develop qualities like analytical skills, business skills, communication skills, interpersonal skills, math skills, and problem solving skills. Now, let's talk about income. As of May 2024, the median annual wage for aerospace engineers was $134,830. The lowest 10% earned less than about $85,350, while the top 10% earned over $205,850. Wages tend to be higher in industries like R&D and government. Employment for aerospace engineers is projected to grow 6% between 2023 and 2033, which is faster than the average for all occupations. Approximately 4,200 job openings are expected each year, driven by an increasing demand for fuel efficient aircraft, expanding satellite and drone use, and growing commercial space ventures. Quiz time! Let's see what you remember. Ready? Question 1. Which of the following careers typically requires a doctoral degree to conduct advanced research and teach at universities? A. Atmospheric scientists. B. Physicist or astronomer. C. Aerospace engineer. The correct answer is B. Physicist or astronomer. Physicists and astronomers usually need a PhD to conduct advanced research or teach at universities. This level of education prepares them for an in depth study of natural laws and the universe. Question 2. What do atmospheric scientists primarily study using principles of physics like thermodynamics and fluid dynamics? A. Aircraft design and propulsion. B. Weather, climate, and atmospheric conditions. Or C. Black holes and galaxies. The correct answer is weather, climate, and atmospheric conditions. Atmospheric scientists study the Earth's atmosphere, including weather and climate, using principles like thermodynamics and fluid dynamics. Question 3. Aerospace engineers apply physics to design and test which of the following? A. Weather forecasting models. B. Telescopes and observatories. C. Aircraft, spacecraft, and satellites. The correct answer is C. Aircraft, spacecraft, and satellites. Aerospace engineers design and test flying machines such as planes, rockets, and satellites, applying physics concepts like aerodynamics and mechanics. Let's wrap things up with a few fun facts. The famous physicist Albert Einstein didn't talk until he was about 4 years old, but he grew up to change how we understand space and time. Number 2. Lightning is about 5 times hotter than the surface of the sun. Atmospheric scientists study lightning and other weather phenomena to help keep us safe. Number 3. The first practical helicopter was invented by aerospace engineers who studied how birds fly, combining nature and engineering. Thanks for joining us. Remember to check out our previous videos on our YouTube channel. Don't forget to follow us on Instagram at Explortle or through email explortle@gmail.com to stay updated. Next up, we have atmospheric scientists. Atmospheric scientists study weather, climate, and the atmosphere. They analyze weather patterns, forecast storms, study climate change, and model atmospheric conditions. They mostly work in offices, weather stations, and research labs. The most common workplaces are NOAA, National Weather Service, TV stations, universities, and environmental consulting firms. Let's find out how much atmospheric scientists connect to the world of physics and astronomy.